So we're going to look for solutions when we have a squared, or when we have a root, or when we have to square a function. So first, I want to remind you about squaring a binomial. When I have a plus or minus b squared, I always get a squared plus or minus 2ab plus b squared. And this sign is the same as the first sign. The last sign is always positive, right? Because if I'm squaring it, whether it's negative or positive, it's going to be positive. Now, you can certainly FOIL it out every time. I just think it's much easier if you remember the pattern. Okay? So we are finding the solutions in the interval 0 to 2 pi. So that means we do not need the k pi or the 2k pi. Notice it says to check your answers. The reason we have to check our answers is when we square both sides, sometimes we introduce an extraneous solution. So a solution that solves the squared one, but doesn't solve the original. So we will need to check our answers when we're squaring both sides. So looking at this first one, how do I know I need to square both sides? Well, there's nothing I can do with that, right? We don't have the same trig function. One's a cosine, one's a sine. We don't have anything squared, so I don't have a way to turn my sine to a cosine or my cosine to a sine, right? There's nothing else I can do there. Everything's already in terms of sine and cosine. There's no common factors. I don't need a common denominator. You know, all of those things that we looked at with identities. There's nothing we can do. So, when there's nothing we can do, we will square both sides. So my left-hand side will become 1 minus 2 cosine x plus cosine squared x equals sine squared x. So now we have squared functions, right? Do I want to turn the cosine squared into a sine squared or the sine squared into a cosine squared? The sine into the cosine, right? Because then I'll have only one trig function I'm working with. So 1 minus 2 cosine x plus cosine squared x equals 1 minus cosine squared x. So let's put everything together. If I add the cosine squared to both sides, I'm going to have 2 cosine squared x minus 2 cosine x. And let's see, I have a 1. If I subtract it, my 1s are going to cancel, right? So equals 0. So now I only have 2 terms to factor, and they both share a 2 and a cosine, right? So I can factor that out. 2 cosine x times cosine x minus 1. Equals 0. So if 2 cosine x is 0, that means cosine x is 0. If cosine x minus 1 is 0, that means cosine x is 1. Okay, so if cosine x is 0, thinking about the unit circle, that is either at pi over 2, right? Or 3 pi over 2. If cosine x is 1, that occurs only at the ordered pair 1, 0, right? Which is at 0. But now we've got to check them. So let's think about pi over 2. We're going to go back to our original 1 minus cosine x equals sine x. So for pi over 2, that ordered pair is 0, positive 1, right? So let's see if it works. 1 minus 0 on the left equals 1 on the right, correct? So that one works. We're good. What about 3 pi over 2? Well, that's 0, negative 1, correct? So if I plug in a 0 on the left, I get a 1, and on the right, I get a negative 1, correct? So that means 3 pi over 2 is an extraneous solution that was introduced because we squared both sides. Then to check 0, at 0, when x is 0, we have the ordered pair 1, 0, right? Plugging in a 1 on the left, I have 1 minus 1, which is 0, and on the right, I have a 0. So my two answers are 0 and pi over 2. We do not include the 3 pi over 2 because it's an extraneous solution. All right, same type of thing here. We know we can't do anything without getting rid of that square root, right? There's nothing to be done until we get rid of it. So to get rid of it, we will square both sides. So on the left-hand side, we have cosine squared x. And on the right-hand side, we have 1 minus sine x. Since we squared it, we're just pulling out whatever's inside that root. And then it starts to feel real repetitious, right? Because now we've got to change that cosine squared to a sine squared. And so now cosine squared is 1 minus sine squared equals 1 minus sine x. If we move everything to the left, I'm going to have negative sine squared x plus sine x. And my 1's are going to cancel out, right? So equals 0. And then I have a common factor of sine x. So negative sine x times sine x minus 1. I factored out that negative. So either sine x is 0 or sine x is 1. All right, the sine of x is 0 when we're on the x-axis, right? So that means we either have, this occurs at either 0 or pi. The sine of x is 1 at pi over 2. Then we've got to check it. So on my unit circle, at 0, my ordered pair is 1, 0. So I'm going back up to my original. I would have a 1 on the left, and on the right, I would have the square root of 1 minus 0, which is 1, right? So 1, 0 works. At pi, we have negative 1, 0. If I plug in a negative 1 on the right, all right, but on the right, I would have the square root of 1 minus 0, which is 1. So pi does not work. And then if we look at pi over 2, the ordered pair at pi over 2 is 0, 1, So plugging in 0, 1, 0 on the left, and then on the right, I would have the square root of 1 minus 1, which is 0. So my answers are 0 and pi over 2. So it is really important that you check those zeros, okay? Let's do one more. Let's do the squaring one. Yep. Didn't we just do this one? Yeah, okay. Let's do this one. The cosecant is cotangent x plus 1. So, again, when I look at this, I go, there's nothing to be done, right? I could turn it all into sine and cosine, but that's not going to help me. But I do realize that if they were squared, I would have Pythagorean identities, right? So that's what we're going to do, is square both sides. So on the left-hand side, we have cosecant squared. And on the right-hand side, we have cotangent squared plus 2 cotangent plus 1. And again, that 2 in there is just from doing a squared plus 2ab plus b squared. Again, if you need to FOIL that out and write it all out, you certainly can. So let's see what we've got here. It's I love cottage cheese, right? 1 plus cotangent squared is cosecant squared. So we need to turn this cosecant into a cotangent, correct? We got to change this guy. So he is going to become what? 1 plus cotangent squared is cotangent squared plus 2 cotangent plus 1. Oh, look at that. Aren't my cotangents going to cancel out? Right, when I subtract that over? And I'm just going to be left with, oh, my 1's are gone too, right? So I am left with 2 cotangent equals 0. Okay, so we did one like this already today. If the cotangent is 0, then that means we're looking at x over y being 0, which means my ordered pair must be 0 and a number, correct? And if we think about the unit circle, that occurs at pi over 2 and 3 pi over 2. So we need to check those guys, right? So at pi over 2, my ordered pair is 0, 1. So I'm going to go back up into my original and think about it. Let's see. I guess we got to do a little work here. So cosecant is going to be a 1, right? And cotangent is going to be 0 plus 1. So that checks. Looking at 3 pi over 2, I'm going to have 0, negative 1 is my ordered pair. So cosecant is going to be negative 1 equals cotangent is 0 plus 1, and that is not true. So we only have one answer here, and it's the pi over 2. So it is not going to be unusual for you to have an extraneous solution, okay? We had one where we had 1, we had a couple where we had 2.